Hi everyone. Nice to see you. I assume you can hear me. Just test test. Um, I think we have 90 people here in the live lecture today. It's obviously being recorded. I think we have about 300 people in the course. So, firstly, congrats, I guess, for getting into this in high demand for some reason course. Seems to be a lot of students are emailing trying to get in, so I guess you're some of the lucky ones in some people's eyes. So congrats, happy year of the ox indeed. um, yes, I can't remember what I think. I'm a rooster, I don't know. So today's lecture is largely administrative. I like to do these one lecture at the start, go through the what, how, why of the course, take an hour, and then try not to talk about it too much again. Not a lot of content's covered today. That's kind of covered in the first lectures this week, but like in the pre-recorded lectures that you've seen. But we'll get started to go through it. And if you have any questions at any point, please just post on the YouTube stream. I have the chat up on one of my screens. Yeah, so let's get into it. I guess the first question that you might ask yourself when it comes to this course, I mean, you enrolled in this course called Web Front-End Development, right? And I think it's interesting because if you go around asking people, like, what is front-end development, you usually get answers that are like, they build front-ends or they build interfaces. But I think a good way to see it in terms of the impact is that you're really building things that touch people, right? Or people touch it, whatever you're building. In terms of, you're making something that people interact with, right? Like there's a lot of programming you can do that's infrastructural or service level, but a lot of what you're doing here, when you're a front end developer, is actually building things for real people to use, right? So it's building the outward facing layer of products to use. And obviously you can take that a little bit further up into the designer UX level, or you can take it a little bit further down into some of the application logic level, because obviously there's a lot of front-end development that can be writing algorithms. I was talking to I think it was a casual employee at Canva, for instance, and they were building front ends at Canva, but most of what they were doing was trying to write algorithms on the front end to make something work. So there's a lot of diversity there, but fundamentally you're trying to build interfaces for users. James has asked, is there a live lecture on Thursday too this week? There is not. We'll get to lectures a bit more, but I'll give you that short answer now. And pretty much everything that's done these days at the moment in the world of front end is done with HTML, CSS, and JavaScript in one way, shape, or form. There are lots of other fancy tools and names and stuff that you'll hear being used, but these are kind of the three core, I guess, technologies. I don't want to call them programming languages, but the kind of three core technologies that drive it. So I think a really great question to start off the course is, why do this course? Now, I don't need to tell you this because you enrolled yourself. I did not enroll you, so I'm sure you have a good sense of why you'd like to do it. There's a reason that I was interested in teaching it. The inception of this course was pretty straightforward. I think there's been collections at UNSW for a while of current students, ex-students, staff members who've been interested in starting some kind of front-end development course. And it was late 2019, I think. There was a couple of people from Canva, Google, Atlassian, UNSW that kind of got together and tried to put this together. And it's like, why are we interested in putting this together? And why is this a far more relevant course, or more broadly, why is this a far more relevant topic than it was 10 years ago, or 15 years ago, or in some cases even 5 years ago? And the reason it's so important now is because the web is exploding, not literally as in self-destructing, but exploding in terms of popularity and use. Virtually the vast majority of what people build these days to solve problems is web-based applications, whereas in the past it was typically more native applications. And what I mean by native applications is Right now you're probably all using some kind of browser like Chrome or Safari or Firefox or Edge. That's a native application, right? It's installed on your phone. But think about everything you do. Most of what you do on the computer these days is probably on a web browser, right? Facebook, most applications you use, Microsoft Teams and stuff, would all use a web browser. But I just wanted to give a really quick understanding of how the web went from something that was big and exciting to just blow, like way out wide. And it all kind of starts in the early 90s. 1993 is my birthday, which I assume is just a coincidence. And it all kind of started with the initial internet, right? And you kind of can define the internet as the network of the world, and you can define the World Wide Web as the part of the internet that's used to basically access HTTP resources via URLs, right? So you've got the HTTP protocol. It's what you type in the URL bar. And that, even right now, is still the standard of how pretty much virtually the vast majority of web applications are made, right? Is they're built off this HTTP standard that holds up the web, the World Wide Web, which is that part of the internet. And it first started off just by this very simple language called HTML, which stands for Hypertext Markup Language, which essentially was just a basic way to put content on a page, right? I want to put a header here, I want to put a link here, I want to put an image here, I want to put some text here, a couple of dot points. It was, Web 0.1, I'm just there to communicate information. So you've probably seen websites like this before. They're just from a different day when the web was a very, very informational thing. As the 90s went on, we had the development of two really important technologies, which is CSS and JavaScript. Now, CSS was really a response to the fact that people were trying to make more elaborately designed web pages, right? Now, with just HTML, there are some interesting stylistic things you can do with a website that make it a little bit nicer than this, but fundamentally, your web pages can't really expand too far. There are some things you can do with HTML. You can color some text, you can add a little bit of spacing to some elements, but mostly there's not too much custom stuff. So CSS was the tool for styling. So people could make pages that look like this. And that was super exciting because the web became a slightly more enticing thing to use. I think a really important way to think about the boom in web is that 20 years ago, there wasn't a ton of restrictions on what you could do with a native application. And by native application, again, I mean, Google Chrome or, what else do people use these days? I'm trying to think of what interesting... What are some fun native applications people use? Like Google Chrome, right? You can do a ton of things with Google Chrome. You can do a ton of things with... I don't even use any. Not that you'd know of, I guess. But... and web was always kind of this really crappy version of it. It's like... if anyone remembers Skype... Like, I don't know if anyone uses Skype anymore. But even when Google Hangouts came out years ago... Google Hangouts was still kind of crappy. You couldn't do a ton with it. You could maybe do some video sometimes. And it was always kind of second to these native applications like Skype because they were built into the computer, right? So we've been struggling with this constant limitation of the web for a number of years. And it's only recently that those limitations have absolutely started to dissolve to kind of record lows. So the introduction of CSS in the 90s, the introduction of JavaScript too. And JavaScript is a language that I know many of you do this course because you know a little bit of web and you want to know more. So I know some of you know it, but JavaScript is a scripting language used for the web. So if you've done a kind of standard CSE degree, the thing you've seen the most like it is going to be Python, right? It's a lightweight scripting language, and it allowed you to actually do some interesting dynamic things on the internet. For instance, when someone clicks a button, you can give a pop-up, you can give a confirmation, you can maybe change the color of something. So JavaScript was the introduction of dynamism, as in like dynamic pages, and CSS was the introduction of the aesthetic, the design, the stylistic elements of it. That kind of carried the web for a while, And in a lot of ways, this was kind of the web that I grew up with young, and a number of you might have as well. Some of you would have grown up with it even before that, because I know we have a couple of older students here. But then there was a real big shift in kind of the early 2000s, right? Like the 2005 to 2010 period, I think, stands out. And that was when we started to develop Ajax as a design pattern, as a method. Ajax is a fancy word, but I just refer to it as background requests. And what I talk about with this is, if anyone remembers kind of older school websites, maybe like 15 years ago, MySpace is a great example. If you had a web page or a messaging app, right? Maybe you had like one of those old messaging apps, whatever form it was. If you weren't using Flash Player, which is a whole other story, you tended to have to click refresh to make things happen, right? Like if I was on MySpace and I messaged someone, I barely remember that, but I would have to kind of like hit F5, refresh the page to see if like my inbox tally would go from 0 to 1. It wouldn't just magically appear. And this was a big constraint with the web, right? Because you had all these other applications like, I don't know, MSN, Messenger Live, whatever, that were just so much more animated and capable and smooth compared to like this clunky web, which was really just a hit a button, send a request, get a static page. You know, even though JavaScript could do some interesting things, it still felt like you were just asking for something and getting it back, and that was all you were doing. But this background request started to come in really around the time of when Facebook started to boom. And in my memory, Facebook was one of the very early messaging applications that wasn't Flash-based, that you could actually have like real-time conversations with without refreshing the page, right? So you could kind of load a page, start sending messages to people, and they'd be sending them back, because even though you've loaded that initial web page first, right? That one where you have the little loading bar at the top and it finishes because the page is done, your web browser was actually still sending all these quiet requests in the background saying, give me more information, give me more information. I'm sending a message, you know, have you got a new message for me? And it would update it. And again, this was another step in bridging that gap between how smooth and useful and powerful a native application could be and how powerful the web could be. Still not quite there, not perfect, but definitely a huge step up. Then, around like the 2010 times, we had two very large developments in my view, which was a tool called Node.js and a superset language called TypeScript. Now, historically, the way it worked was JavaScript was like an engine that was deployed to a web browser, right? So your web browser takes JavaScript, some language, and it runs it through an engine to do things. You know, you've seen this all the time. You know, even like I have this web page up here, which I'll show you, which I was going to ask for people to vote for something at the end of the lecture, just to give some like feedback. And you can see here, right, very simple web page. This could pass as like a 2010 web page. Now, JavaScript was what allowed us to do really basic things like this. You know, swap between tabs. And, you know, click on this button. You know, it just allowed us to do some basic things. And it got more and more advanced, and we got those background requests. But Node.js was a deployment of JavaScript that wasn't on the browser, but it was on the server. So suddenly, instead of doing what you used to do, which is you used to maybe write build a website in JavaScript, like a front end in JavaScript, web page, and then you go and build a server in something like C++, .NET, Python, PHP. Node.js started a trend where you could now write back-end server-side applications with JavaScript. Now, like, why was this exciting? Well, because suddenly managing web applications became a little less onerous, because when you have some native applications, sometimes there's some like Java's a great example, right? A number of you might have done COMP6080, and you know what Java's like. You can build a Java application which is like a full stack. You know, your front end's written in Java or your logic's written in Java. It's a nice little Java package. And that's really appealing from a software engineering standpoint because it's nice and contained. And the big struggle with the web historically was, okay, you got to build your front end. It's all up here in JavaScript and HTML and CSS, but then your web server is written in this other thing, and blah blah. And Node.js was suddenly an ability to write your backend in the same language that your front end was written in, and very quickly that made it more appealing for large-scale projects because now you had one core language which you could standardize. You could get developers competent in JavaScript working across the stack. And it made it a lot more industrial, really, at scale. And then TypeScript also came along later and essentially is a kind of advanced version of JavaScript, if you will, that made it a typed language, to oversimplify it. So JavaScript by default is more like Python than like C in terms of it doesn't have types. You just write code and it just runs and figures it out while it runs. And that's okay. And it wasn't so much like C, where you have your types and all this stuff's done at compile time. And it's like, oh, sorry, but you just assigned an int to a char. And, these runtime systems like JavaScript were all well and good, but for large, high reliability infrastructure, it's just not good. Because things go wrong, right? Like that's kind of one of the basic principles of software engineering. You don't like finding out problems at runtime. That's why writing Python systems just feels a little bit dangerous sometimes because you think anything could happen here because there's very limited checks. So TypeScript also made it a lot more appealing for larger institutions, right, to take this on because they're like, okay, this is making this language a lot more reliable than it used to be. So these kinds of old arguments about, oh, you've got these really old school languages with really strict typing like Java, a lot more reliable, a lot more predictable. Again, those barriers decreasing. And then, what does it last to? Yeah. So, these two aren't really in order. This isn't really chronological in these last ones. But there was another massive boom that's made a huge difference in the last years, which is these idea of hybrid apps. And basically, this was where people started saying, hey, you know what? Websites are getting pretty darn advanced now. Like using Messenger or using Discord or Slack, you're like, it's kind of starting to behave like a native application. So these barriers finally kept getting wiped, less and less and less barriers. So they started developing tools, and we're going to talk about some of these at a very high level later in the course. We're not going to do much demonstrative stuff with it. Like Electron, like Apache Cordova, where it allowed you to actually build a web app in a web browser, but then package it up as if it's an application. And it's funny because, some people, there's a chunk of people that know this, but Slack, Discord, Microsoft Teams, there's probably some more, but they're the big ones I know of. They're all actually websites, right? In terms of they're built with web technologies and just packaged up in like a separate web browser, if you will, without the header, without all the stuff around the outside. Because if you think about it, like that's all some of those applications are. They're basically a website without your Chrome header. And then they just ship them as native applications because sometimes it's nicer to work with applications that aren't just another tab in your browser, right? Because you open 100 tabs, you lose track of the Microsoft Teams thing. So this has done huge wonders for the popularity of web because now we can just like build something in web language and ship it. And it feels like a native app. It's a little slower, it's a little clunkier. If you pay a lot of close attention, it's still not quite there compared to a native app, but again, it's helping bridge that gap. And then the last one, which is what a big part of this course is on, is this idea of declarative frameworks. Now, there's no point in me explaining this much, because if you haven't worked with them, it's very hard to appreciate, the specifics of what these are. But basically, JavaScript itself was never really written to build modern, heavily interactive, heavily state-based applications, right? It just kind of wasn't. And this will become more apparent to you as you work through this course. But it was very easy to build something in JavaScript on the web that became spaghetti code very quickly. Right? It was just... That's why you'll hear people... talk about like you'll talk about JavaScript. They'll be like, "Oh, what's your favorite language?" And if you like JavaScript, you'll get about probably half the industry be like, "Ugh, gross." That's scary. And it's because JavaScript is not a it's not really it's very anti-Python in a way, right? Like Python is a very simple, strict pattern-based language, and JavaScript is like the Wild West. Like the raw JavaScript is really easy to write really bad code with it, and the language syntax is a bit weird. But declarative frameworks, Angular, which I believe is getting decommissioned, Angular by Google, React by Facebook, and Vue. I can't remember who wrote Vue. These are just frameworks that big tech companies wrote because they said, you know what, we're sick of working with this raw JavaScript, so let's build something that makes JavaScript easier to work in. And this is going to be a big part of this course as well. So these declarative frameworks have had a big help because suddenly the ability for people to write complex applications that are reliable and functional has also gone up. And you can see that this is a chain of events that is really helping lead to this boom. And, it'll probably continue for some time. There'll be things that aren't ever going to be made on the web, but, it's becoming increasingly popular. Yeah, I've kind of said that already. Great. Okay, that was the fun stuff. Now we're going to get into the course administration. But before we jump into that, does anyone have any questions just about not about the course specifically, I guess? Like not about labs or whatever, just about anything to do with like web historically. There's a slight lag in the YouTube, by the way, so when I ask questions, I'll sit here quietly for 10 seconds, even after you've maybe answered them, because there's like lag. The last date I gave was 2014. Has much happened since? I mean, yeah, a lot of the stuff has been advanced. I mean, I think something to remember as well is these dates are when they're released, right? So like Node.js was released in 2009, but I tell you, I really would struggle to find many people that have been using Node.js for more than the last 5 or 6 years. Because a lot of these things are released and then it takes a while for people to like them enough, and often they're open source as well. So adoption takes a while, and the more it's adopted, the better support it gets. Has some teething issues. So, again, even though TypeScript was released in 2012, I really haven't seen people using TypeScript commonly more than 3 or 4 years ago. So I think account for some lag in this. Like Vue.js is the same. First time I really heard of anyone actually doing anything in Vue.js that I know personally was like 2-ish years ago. I'm sure it happens. That's not the point. It's just like there's a little bit of lag into these things. So yeah. What was my first web app? That's a good question. I mean, I like that question because it also leads to another question, which is, what's the difference between a web app and a website? Which I don't think is a formal definition anywhere. But when someone says something like a web app, typically what they mean is a website that has a feeling that it's more like an app than like a site, So, like people would call YouTube a website, but they call Messenger like maybe like a web app. All right, anyway, my point was like, what's my first web app? I don't know. I don't know when the first time I tried to write something that was very app-like. My first years in web, the first time I made money from web development was 2007 or 8. That was back before a lot of this stuff. This was kind of like this time-ish here. I don't remember the web before Ajax wasn't a thing, but these background requests weren't really used super heavily back in the day. Browsers have also gotten a lot more capable, which is a whole topic in itself. I said native app does it normally means C/S. What do you mean by C/S? Sorry. So Hong Tao says you said native app doesn't normally mean C/S. All right, wait on an answer for that one, and we'll just get ready to move on. I doubt we use the full 2 hours tonight, but we'll see how we go. Again, I'm not too sure on your question, but like native app means it's installed on the system itself, right? So like when you install a program, basically, this is actually one reason why there's also a push towards web applications. Like it's not just because people love JavaScript. The other reason is you can actually think of the web browser like a virtual machine, right? If you have some knowledge of computing, you know that you might have your computer and then you can install another operating system on a virtual machine. And sometimes it's great to do things inside that virtual machine because it's kind of safe in there, right? Like your virtual machine is like contained in this space where it's difficult for it to like break out of there unless you let it out. It can't just go and read things off the host disk unless you let it read things off the host disk. So another big reason why web apps are hugely popular is because the web browser, while it's not a virtual machine in any sense of the word, it is like a sandbox. It is an environment that's very well contained. And that actually means that it's very hard to, like, if you download a program that's dangerous, every time you install a program, you have to give that program, unless it's a portable, you have to give that program some kind of privileged access, right? It for a moment, when it installs itself, it can do whatever the hell it wants, so you have to trust it. Whereas with websites, you can kind of go to every website you want. You're not going to get any virus from trolling the web unless you actually download something and install it anyway. So that's another reason why web has become quite popular. And that's also one reason I try not to download too many. I download like Slack and stuff because it's a lot easier to use locally, but I try not to download too many native applications that I can use on the web because it just exposes you a little bit more. Okay, let's chat about the course. So this is a new course. This is the second time it's happening. I know many of you know that because you were probably interested in it last term. And we're going to go through a few of the assumed knowledge pieces and learning outcomes. So assumed knowledge, we assume that you have a knowledge of two basic things that some of you won't, which is we assume you have a basic knowledge of Git, which is the version control tool. We don't expect you to be super proficient with it, but we expect you to have a basic knowledge of it. We also expect you to have a basic knowledge of HTTP and web browsers. And when I say basic knowledge of that, I mean very basic knowledge. I don't even mean network theory. Like, if you know that 404 means page not found and 200 means success, that's like probably more than enough for the sake of this course. If you've done COMP6080, which I guess many of you might have done that with me, then you also will have absolutely an adequate amount of knowledge. You don't have to have done networks. For those who feel like they want more knowledge on the topic of Git or the topic of HTTP, in the sidebar on WebCMS3 we have linked a couple of Git resources that you can learn. Generally, like, these are overkill in terms of these go into a great deal of depth, and there's an Atlassian guide as well, but they give a really great theoretical understanding. And then there's also some COMP1531 lectures from 20T3. In particular, I would just want to highlight to people that there are two kind of big lectures here which people might find useful. If you feel like if you're a postgrad or you're a credit transfer, and the word HTTP request scares the hell out of you, then I would probably suggest that you maybe go and watch these 4.2 lectures here. You could watch anything else. You don't have to watch this. It's just, I know it's here because I made it. And it mainly teaches you about what backend servers are and how backend servers work. And that's kind of important because in this course, we're kind of doing the opposite, which is that you're not building a backend server for someone to use. You are building a front end that uses a backend server. So you are interacting with the web and HTTP from the client side towards some kind of system. Yes, and we assume you have a basic knowledge of scripting languages. And what I mean by that is Python for many of you, because 1531's a prerequisite. If your only background is in C, you should be fine. There may be just a couple of confusing things, because JavaScript is a lot more like Python. And, you know, there's some things like maybe lambdas or loosely typed aspects of the language. The more easy way to deal with lists and dictionaries and data structures, as opposed to C's kind of more rigid style. As Happy Forever says, how can we watch this list? It's in the sidebar. You can just go to COMP6080 lectures, just in the sidebar. It's totally fine. Asako says, I previously used GitHub but not GitLab. Is that relevant? No, if you've used GitHub, that's more than adequate. They're all roughly the same. Vishal says, would we cover databases in the course? So there is no server side. There is no real server side work in this course. That's mainly just because it is big enough already. Like, this is a hard course to teach, because if you come into it with a good knowledge of web, it's a little bit slow. If you come in it with a bit of knowledge with web, then it's quite manageable. If you come in it with no knowledge of web, as in no prerequisite knowledge at all, you've never written an HTML page, it's very doable, but it's kind of like we wouldn't want to make it any harder for people. You know, in that sense, it's hard for us to squeeze much more into the course. Kevin's asked, will you give us a quick tutorial on how to set up an IDE for front-end development, software packages, compilers that we need to install? That's a great question. Maybe later in the course, but to be honest with you, like particularly in the earlier weeks, I mean everything I do, even day to day, is still just in a like an Atom or Sublime or vanilla VS Code editor. There's very few like most of the packages that I have installed for my work-related purposes are to do with TypeScript or linting or some other things that are kind of beyond the scope of the course. So if there's specific things you want assistance with, probably let us know, but I don't think we have any crazy IDE set up, particularly because it is an introductory course. So and most IDEs in general usually try and help people who already know what they're doing do it faster, right? So usually I assume that the people who want to be like, who are already like that, are kind of comfortable enough to set up an IDE, but let's keep exploring that topic. I think it's interesting. I just don't have anything for you at the start, particularly because it's quite, HTML, CSS. The fundamentals of what you're learning in this course in terms of learning outcomes are writing a lot of JavaScript, understanding HTML, CSS, and the DOM, basically web browsers. How do they work? How do you write HTML and CSS with them? How do we work with declarative frameworks, which in this case we're using React.js in this course. Why do we use React.js? I think there's 3 reasons. I use React.js, Canva uses React.js, and it's the most popular one at this current point in time by a long shot. That'll probably change in some years. Some people argue that it's a little bit more complicated than Vue. They're probably right, but okay. That's just life, I guess. So it's perfectly fine. What I usually tell students is, if you learn React.js, you're going to be learning probably one of the most ubiquitously useful skills. You could do this course and go on freelancer.com and have work for years. So, regardless of your degree, so it's not a huge problem. We want to talk a bit about asynchronous programming. This is a topic that actually doesn't come up in a lot of other courses, because most languages are kind of quite synchronous by default. JavaScript's kind of not like that. And what I mean by that is, in JavaScript, it's like, in other languages like Python, when you say in Python, I want to open this file and read from it, Python is kind of by default serialized, in the sense that it will execute your code, and when you say file open, it will just sit there and wait till the file's open, and it will keep going. A lot of JavaScript is designed to kind of be asynchronous, which creates some challenges. Basic knowledge of front-end security. There really isn't going to be a lot of that in this course. We just want to have a tiny bit of it somewhere. So don't expect this to be major. And then also just a little bit on UI UX design and accessibility, right? This is not a design course. I'd love it to be a design course. CSE does offer 2 user experience courses, which are, I think they're called human-computer interaction, and I can't remember what the other one is called, but it's COMP3511 and COMP4511. That's really where the idea of what makes a good interface is meant to go. We like to talk a little bit about this, about 10% of the course roughly. We want to talk about what makes a good user interface and experience, what makes an accessible product, but it's very minor. Again, I'd love to talk more about product building and user experience, but fundamentally what this course is it's a technical course on building front ends. It's the kind of thing that you would not go away from this and be a UX designer. You would go away from it and be a front end engineer. So, yep. And then this is an extract from the course outline, just about the topics we teach. So there are a handful of topics in the course. We learn about basic old school JavaScript, which we do a lot of at the start, and then we taper off pretty quickly towards the middle of the term. We learn about JavaScript frameworks like React.js, which are the modern ways of doing JavaScript, and we kind of learn about that as term goes on. The way that like, and I take responsibility for this for better or for worse, because some people don't like it, but I still stand by it, as the way this course is taught is I don't like the idea of teaching the modern frameworks at the start, right? Because I think that it's very important to understand what they're built on top of. I'm not a purist, but in this case, I don't think it's healthy for people to learn a framework like React.js without understanding how JavaScript works. So if we taught React first, it would feel fine, but I think you'd miss out on a lot. If we taught Vanilla.js first, if we only taught Vanilla.js, I think we'd be doing you a disservice in terms of your ability to actually meaningfully create things after the course. So then we say we teach both. Okay, well, if we teach Vanilla.js for half the course and then React.js for the second half, my problem with that, in my best judgment, is that React is complicated. And you can't learn it and do an assignment on it and an exam on it in like 25 days or like 30 days or whatever the hell 35 days, 5 weeks is. It's just your brain does not absorb information that quickly, right? It's not how many days you have with a topic, it's kind of how many weeks you have with it. So because of that, what we do is, like, as of week 2, we give you just a little React activity, just a little one. And then week 3, we give you a little bit of a harder one. It's still pretty easy, takes not very long. And we just kind of amp that up so that you're kind of exposed to it very early on. So that you can like keep getting familiar with it. So that by the time we really need you to pick it up hard in like week 6 and 7, you've already done enough basics to like be familiar with it. So that's the strategy there. HTML and CSS is mainly covered in the first week. As you've seen, we kind of just punch it, hit it hard. There's a few reasons for this. One reason is it's easy. So it's good to do it early because it's also when people enroll late and they're settling in. So it's just not as intellectually challenging, which is useful. And then we have our UI UX testing and infrastructure stuff. Testing comes in later in the course. Testing's important in everything you do, but I think it's a reality that when you're learning a new language, no matter how important testing is, no matter how much we say to test, if you're going to spend 6 weeks just trying to understand the basics, then let's just let you understand the basics and we'll worry about testing later on. There's some questions that students always have about the course. Why not TypeScript? Why React? Why are we using Chrome? Why are we learning that? There's an FAQ here linked in the slides that you can look at. Okay, so who's actually teaching this course? Well, we have a team from UNSW, which consists of myself and a handful of great tutors: Anto, Clarence, Daniel, Emily, Hoya, Justin. I think Justin was in the YouTube video, the YouTube chat I saw. Kai, Marina, Maria, Melanie, Ravija, Simon, and Surya. Great tutors. Some of them taught the course last time. Some of them, what would you say? Some of them have done the course themselves. We also have Zane from Google. Zane's a UNSW alumni like myself, and he helps out with some of the asynchronous topics. And then from Canva, We have a bunch of people who've helped get the slides together, which is, you can read the names, but Anna and Tom are UNSW alums, so they've also studied at UNSW, just like me and Zane. And the rest are kind of just floating around. And then there's some other people at Canva who help provide a lot of the support, but don't actually record some of the videos. Which I guess kind of leads to that question, like, what is Canva's involvement here? So, Canva and Google, I guess, helped work with me to put the course together. Canva just like footed the bulk of the let's record some material to help people learn things. So, yeah. Okay, assessment structure. Because you're all social creatures and you no doubt talk to other people, you've probably talked to people about the course before, right? Like some of you haven't, but I know a handful of you would have. You've got a friend doing it, you've got a friend of a friend doing it, you something. It's important to flag that in 20T3, we had labs in this course and they were accessible. So it was like 1511, 1521, 1531, 2511, 2521. You have labs and you do them and you get marked for them. There was reasons we did that on the first offering, even though we weren't certain about it. And we're glad we did. And upon reflection, we've changed that. So now the course is pretty much just 75%, 3/4 assignments, and then 25% exam. This is not a hurdle exam. I don't think hurdle exams make any sense if they're open book exams. That confuses the hell out of me. And your assignments are due in weeks 3, 7, and 10. Respectively, they're worth 15, 30, and 30. I believe that's written up on the assignments page. So assignment 1, 2, and 3 here. First one's quite light. The second two are worth 30% each. The assignment 3 is also optionally a team assignment. And when I say team, I mean pair. So you can work on this with another person if you'd like to. We'll talk more about that later in the term, but I would strongly recommend that everyone works on that with a pair. Because, well, I don't want to say that. There's a little bit of extra work if you do it with a pair, but generally things are kind of easier if you do it in pairs. But we'll talk about that later on, because that's like weeks and weeks away. Happy Forever Happy Kitten, that's a weird thing to say out loud, has asked what type of questions will be in the exam. So the exam, that's a great question, Happy Forever Happy Kitten. The exam is going to essentially be a speed coding exam, which I shouldn't even say that because that phrase is going to haunt me. But we kind of get you to build a mini application, like something that's much smaller than an assignment, and in 4-ish hours. And I thought a lot about this, and here's my 2 cents on it. Someone's ability to code quickly is not really that meaningful, right? You'd rather code properly than quickly, right? Everyone gets that. That being said, in my experience, kind of having worked in industry groups for, I don't know, 4 years in web now, one thing I've also learned is that there is value in being able to work fast-ish sometimes, right? Like it's quite common. You have deadlines, something needs to get done today. When I say fast, I don't mean just like type in like crazy, like some cliched cinema thing. I literally just mean like someone says to you, "Hey, we need to get this done today," and you're like, "Oh shit, I better get it done today." You just sit down and you get through it. You can't afford to go away and think about it for a whole day because something needs to get done. So the exam is kind of like a mini assignment, except there's like a time limit on it. Just to and it also helps us actually test how much you've retained, right? Because the more you retain about concepts and methods and everything else, the less you need to look up in an exam, right? And in industry, that's also a useful thing. No one knows everything off the top of their head, right? Like everyone Googles everything all day, but if you're having to Google things all the time, literally every time you do anything, then you're going to be you're not going to be proficient in what you're doing. So there's a fine balance to strike there. Yep. Okay. Teaching methods. So we have this. This is where it gets, I think, a little bit complicated. Exams open book, no double pass, no hurdle, no hurdle on the exam. Most people pass the course before the exam. Well, most people, I don't know. Maybe like half the students pass the course before the exam. So, no one in T3 was that stressed about the exam, and it's fine. So with this course, we essentially kind of have like you are expected to watch about 4 hours of lectures a week, and the general idea is that we have 2 hours of pre-recorded lectures and 2 hours of live lectures. Like roughly, some weeks it's not quite the same, but we want to try and keep it to like 36 hours of lectures across the entire course. So you will see that on the lectures page, there's a whole, on the lectures coursework page, there's a whole bunch of pre-recorded lectures. And there'll be more of these. And then we kind of have this one live lecture every week. The point of the live lecture is, I think it's a couple of things. One is it gives us some space to fill in some gaps if we didn't plan for them. It's more fun because, like, I'm here, I'm sitting in my bedroom at 6:51 on a Monday night. Like, we're all here together right now. Maybe that's the end of the list, I don't know. So we also do go through some formal topics in here. It's not just crapping on about nothing the whole time. But yeah, it's you get a bunch of pre-recorded lectures every week. In general, the lectures are most likely going to be on Thursdays throughout the term. This one we try and do on a Monday because it's right at the start of the course, and it's kind of useful if we chat about some things before your first tute, before your first, like, you know what I mean? Like, it's just good to get in there quite early. So generally, I doubt we'll be having many of these on a Monday night. Most of them will be on a Thursday, but I'll be updating you every week anyway. I mean, you don't have to keep the times free because they're recorded anyway, so it's up to you. Tutorials, these aren't marked. There's no marks for attendance. There's no marks for work. You just rock up to a tutorial. Your tutor runs through exercises. You can ask them questions, have a bit of fun. You do that for 1 hour a week, and all the tutorials are listed here. Right? Now, this thing is a slightly more complicated. Can I make it open in a new tab? I don't think I can. No, I don't think I can make it open in a new tab. Wait, links on that lecture page. Oh, you mean these ones? Like the videos. Yeah, I'll try and do that going forward, and I'll try and fix them up in hindsight. I'm sure you know this because you're probably doing something else, but you can just middle click on links or right click and open in a new tab pretty quick, but I'm sure you know that. But I'll try and make it easier. I understand how annoying those things can be. They annoy me sometimes. Okay, so here's the thing. Control click, there you go. Even though we're not assessing any labs, UNSW still timetabled as labs, and you've probably seen that, right? Because on the timetable, there is like 3 hour chunks, right? It's like a first year course. 1 hour tute, 2 hours lab, etc. Now, because labs aren't marked, we were thinking, what the hell is that time actually going to be? Because normally labs are kind of defined by marking something, right? And getting some help about labs. But also, because realistically, many of you won't be doing the labs in that week because you're students, and like many students, like, you just don't want to do the work on time, right? We kind of changed how we think about these times. So even though you don't have accessible labs, we still give you labs to do, right? They're labs from last year that we're going to be adding some extra questions to. But you can kind of go to them here. This won't work for me because I'm an admin, but and they're not accessible. You don't have to do them. You can just look at them, read them. At the end of the week, we release the solutions. They're just there to help you out. So what these lab times essentially become is in the 2 hours after your tute are really just help sessions. In terms of tutors are going to be there. You can talk to them about the tute questions. You can talk to them about exercises. You can talk to them about the assignment. It's going to be run like a help session with Hopper. So like, it's just a help session. So the way that we've written this as a timetable, and I hope this makes sense, is we've just written your tutorial times here and the tutors, and then all of the lab times we've just written as help sessions. So like, you can go to any ones of these you want generally. If they're full, it's really nice of you if you don't fill them up more if you're not actually enrolled at that time. But like if I was enrolled Tuesday 4 p.m. to 5 p.m., I'd maybe go to the tute. Right after the tute, I'd go to the help session and ask some questions. Some help sessions have more tutors on them because there are 2 tutes running at the same time, right? These aren't sessions where you're going to get more help. These are sessions where there's double the labs, double the tutors. The only thing I will say is that I'd really like it if possible. You can do what you want because you're adults, but I don't think it's going to be okay for students who aren't enrolled in in-person times to go to the in-person labs or tutes because of COVID, like social distancing requirements and all that stuff. So, try and utilize that. Just be wary of that. So if you're not enrolled in an in-person one, I don't know how wise it is to try and go to one. But I'm sure, like always, not everyone will turn up. But maybe, like, some of you'll have friends. I'll tell you in a couple of weeks how the attendance is going. But you can go during that times and get help if it's not full, because we can't fill up any like rooms. Like if the rooms are full, the rooms are full. You can attend any tutorial you want. Tutorials aren't marked, and also like if 100 people attend Maria's tutorial and none of them attend mine, okay, it's not going to make a difference. Most people aren't that interactive in shoots anyway, right? So, yeah. So anyway, that's the point. Labs are help sessions. And then we have our 3 assignments, which are out throughout the course. Okay, if you need help during the course, first place to go is always the forum on WebCMS3. If you click on the forum here, it'll take you straight to the forum. You can ask questions. Super fun. If something's too hard to ask a question on Ed about it, then it's good to go to a help session because you can kind of, actually show your code and get a bit more help. And then if you really can't get a problem solved, and I don't mean a technical problem, I mean like if there's something that's not appropriate for those 2 forums, then please just email me COMP6080@CSE, and I can help you out. We have just a few more slides and then we'll take a break before talking about assignment 1, so give us another 5 or 6 minutes. In terms of getting set up for the course, there's lots of technologies you'll need to work with. All of these are run really well on your local machine, even if it's Windows. So you can install Node, NPM. I mean, most of you have a web browser that runs HTML, CSS, and JavaScript. And in fact, most of you only need to install Node.js. So, I think there's some instructions that we're going to put up tomorrow or something about like how to set up Node.js. But it's very, very straightforward. You can also do this course on VLab. Most of you won't do it on VLab just because I think the thing with web development is you tend to need a lot more space because you're looking at visuals. So I think VLab's kind of constraining because I know many students out there will have a second monitor at home with their laptop or something like this, or maybe they'll have a bigger one than a VLab window. You can do everything on VLab though. And we'll talk a little bit about GitLab too. Someone asked a question, is there a standard submission penalty for the assignments? Yes, there is. All assignments are 2% off the maximum mark per hour. I sometimes get criticism from people that's a harsh late penalty. If anyone feels that way, my counter to it is, we give you like often 18 days to do an assignment. Giving you an extra 2 or 3 it's not going to change your fate. If you're going to be unorganized, you're going to be unorganized, and that happens sometimes. The second thing is, I don't want you working on an assignment 5 days after it's due. It makes it harder to mark people's assignments. It also makes it harder for you to get on with your life, because often I make the assignments due very shortly before we release another assignment. So I don't want to be releasing assignments for people telling them to start assignment 2 when they're still like submitting assignment 1. So anyway, that's I'm not saying that you don't agree with that, but you know, that's the rationale behind the 2% per hour off the maximum. So you can like if you submit it 1 hour late, like what are the odds you're going to get 98%? Statistically, you know, about 90+% of you won't get that. So like it takes a little bit of pressure off when it's just off the maximum as well. I think we'll talk about GitLab when we talk about assignment 1, which we'll talk about at the end. We have this file called resources page where essentially like students and tutors have just shared like, oh, this is a cool thing, this is a cool link, I like this one. There's a really cool one called Flexbox Froggy, where you have to you have to move the frog onto the lily pad. So if you, I don't know if anyone's seen the first week's lectures, but if you have, there's like, you know, you like can put in some CSS here and now it's on the lily pad and you're like, oh, I did that. So, you know, these are fun little activities. So you can check out the resources page. You know, some stuff here. If you have any things you like, you can just email them to me as well. I'd always love to look at them and put them on. We'll put on whatever we can find. Okay, there's also a style guide. This is an informal style guide. There is no strict style guide really in this course. There's sort of one for assignment 3, but largely it's not really. This is mainly here just because some people ask me, do you have a style guide? Not because like we mark you, but because some people just like the structure. They like to understand how different places do it. So, you know, this isn't a huge thing, but it's just a little thing. And then last 2 things, feedback. On WebCMS3, we have a feedback link. When you click on it, it takes you to this feedback form where you can give feedback. So you can, I should change this to exercises, but you can give feedback on shoots or lectures or labs or, you know, what you want in the lecture, questions for industry recruiters. You can click at any time. I do love it when you put your name there. Like, I'm not a scary person, I don't think, and like if you say bad things, I'm not going to be like, I'm going to find that person. But it's useful when you write your name because, like, I mean this, about 2/3 of like constructive criticism people give is really useless without the ability to follow up a question. And I hate that. I hate when people leave feedback and I think, well, I want to have I just want to ask you a couple questions to learn more. Because I don't know who you are, I'm just going to have to ignore it. Because it's very hard to do some things without context. So if you're feeling brave, you should put your name there too. It's always just really useful. Sometimes people say, I want to learn about this in the Thursday lecture. I want to learn about X. And I'm like, what the hell is X? I have no idea who you are, so I can't even do anything with that. Okay. And then last one is just getting along. So please remember that you are all bound like me by the... Well, I'm not bound by the student conduct code, but we're all bound by UNSW's code of conduct. Don't be mean, don't be rude, don't be weird, you know, the usual drill. We all know that weird things happen, but just don't be weird. Be good people and try and help each other out. This course went really well last time because I think we had a lot of good students. The very last thing I want to just encourage people to do is when you watch a video... Where's one that's not me? Sure. When you watch a video on YouTube... Oh, God. What? Did I link that wrong? Oh my God. Sorry. Sorry if I've got a bad link there. Are these? Oh. Did I screw up these links? Okay. Sorry. I'll fix these links up. Bugger. Okay. I must have not hit save on the page last night. Sorry about that. So we've got all these videos, and what I'd really love for you to do is when you watch a video, if you could give it a thumbs up or a thumbs down and then maybe make a comment, and just like, because this is like how we get feedback, literally. So at the end of the term, we look at the thumbs up and the thumbs down and we go, that was liked, that wasn't liked, and then we look at the comments and we learn stuff from it. So when you've done a video, if everyone, I mean, most of you won't, but if everyone can try and remember to just vote and optionally comment, then that would be excellent. That would make me very happy. So thank you for that. These two videos, like all these videos, should be fixed after the lecture. One thing I will just flag, these two videos, due to some time constraints with people at Canva, the planning on the re-recording of these fell through. So I'm going to be recording these and doing so in in the next 48 hours. So kind of like by Wednesday evening, it'll be there. Hopefully sooner. Not that it's critical. These things aren't really even critical for the first assignment. So not that critical. Anyone who needs these lectures in the next 48 hours is probably so confident with what they're doing that they don't need these lectures. So, but yeah, sorry about that. Sometimes Canva falls through. That's understandable. Most of the people at Canva are full-time staff. They have their own things to do. Obviously, their work is a priority to recording lectures. So sometimes I have to record those lectures. Don't be alarmed by the fact that most of these first lectures are me. I had to record most of week 1 for Canva last time. But many of the videos, many of the pre-recorded videos in the course are not me, thank God. So, yeah, look forward to that. Okay, we're going to take a 5-minute break. Maybe let's come back at 7:13, just as a random time, and we will talk about assignment 1. And that won't take us 40 minutes, so we'll be done before 8. And yeah, so come back in 7 minutes. Great. Hey everyone. Congrats. Most of you have stuck around, which is always impressive to see. Okay, we're going to talk pretty briefly about assignment 1 and about GitLab, and then we're going to kind of do any last questions, see how that goes. So first thing, this course is run on GitLab. Now, thankfully, that won't have a huge impact on many of you because you're not submitting much work, which I think is where most of the difficulty has. For the average user, what that kind of means though is that if you say want to go to the tutorials and then you'd like to download this tutorial to kind of maybe do yourself, then on the page you have to go up to the top here and you have to click clone, and then you have to choose this URL, and then you can open some kind of Linux terminal and follow the kind of Git processes. Now again, if you're not familiar at all with Git, you should really go and read up on some of the material, because even though you don't have to do much with it, it might be worth understanding some basic things about it. This repo is huge. Why is it so big? Oh, it's all the tutes, right? It's all the tutes and it's like everything. Actually, we kind of did this. We put all the tutes in like one giant repo, so you kind of only have to clone this once for the course, which is pretty useful. So, there's your lectures and tutes and stuff. So tutorials, Tut01. It's all in here. You can play around with that as much as you want. But your assignments, in particular, are important because they are... just increase my volume slightly. Okay, sorry, I'm just increasing my volume because it's better to have it too loud than too quiet, because you can tone me down, obviously. Is we have, as of tonight, deployed assignment 1 repos to everyone. And what I mean by that is that if you log into GitLab and go on this main screen here, you will actually see, I'm just going to pick a random person, Andrew. You will actually see Andrew's got a copy of the assignment now. So what we do in this course is that we create a repository for like the assignment, and then we have some automated systems that go and create a copy of that in every single one of your GitLab accounts. So So this is Andrew's specific assignment. And if Andrew clones this, Andrew can work on it, commit to it, push to it, and it's all in Andrew's private repository. And that's how the assignment works. Now, how do you submit an assignment in this course? Well, the way our systems are set up is that you don't actually submit an assignment. You simply, what we do at the due date, and after a couple of days after, when there's like the late penalties, is we actually do a course-wide grab of your master branch. So it's kind of cool in a way, is that you don't actually physically need to submit something. What we actually do is we just take your master branch when your assignment's due. So if your assignment's due tonight at 8 p.m., at 8 p.m. we go and take a copy of all the students' master branches so that we have a copy of your work. If you submit it late, then we detect that too and stuff, so that's all fine. But the point is, you don't have to run a submit command at all. You can simply just have your code up to date, which is really handy. Now, the first assignment, it's pretty easy. We've reduced the weighting of it from 20% to 15%, because it used to be 20% last term, and we've also decreased the amount students have to... Sorry, I didn't want to blow your ears out. What students have to do in it. So the background of it is that working with HTML and CSS is a very basic skill that it's really important for anyone who works in front-end development to have a firm grasp on. And one of the most important things that you can do with those languages is see something that you want to build and build it, right? And that's what a big part of this assignment's on. So what this assignment is basically 4 different web pages that you have to build. By the way, anyone, you can see your assignment right now. If you just go to the GitLab homepage, it's probably sitting up the top here. I obviously have 2,213 pages because I think I see basically every student's work across a couple of courses, but you'll see only a couple, which will be very helpful. And the first page is quite simple. In fact, you can see it right here. We basically say to you, okay, well, we want you to build a web page that looks like this, that has this text, and it has this gray box over here with this title and this text, and has this little yellow thing here, and it has this title and this text and this title and this text and this link. Very straightforward. Now, before you freak out, we do actually give you like assets for these things. So in the case of, say, task 1, if you go into the task 1 folder, you'll see that this is the page that you write your code in, the HTML file. This is the actual page we've asked you to build. And then this is the text that makes up that page. So all the text on that page is actually given to you in a file, so you don't have to like read it off the screen, which is even harder because it's in Latin. I wouldn't want anyone having to type up Latin. So that's task 1. It's actually very straightforward. You just need to make an HTML page that when you load that HTML page, it looks like this image. Now, like, a common piece of feedback that I hear from people is like, why do we have to copy an image? This is kind of stupid. If I was in the workplace, I would be given like a Figma file or, something that tells me all of the dimensions and heights and colors and all of that. And what I would say is like, that's kind of true, but also that's like at big tech companies that are like really well funded. And the reality is not everyone here is going to go to work for big tech companies. Not that that's a bad thing. I think there are lots of good and bad things about big tech companies, but many of you will work, in areas of, maybe consulting or other kinds of contracting where you might work with less experienced clients who, maybe they send you an image and they say, I really like this web page. And maybe you don't have a designer. Maybe you actually just have to do some really basic analysis of things yourself. And these web pages we give you don't actually require you to do that much extensive stuff at all. So it's totally fine. Amel says, is there a specific screen size? That's a great question. So what we actually give you in all these questions is we actually give you a specific like window size to work with. This can either be the window of your browser, or you can literally make a giant box of that width and height. If you want, like just a div or something. It's totally up to you, but we give you that size so you're not kind of guessing what what scale you're kind of working with. James's joke's quite funny in the chat too. Yeah, so that's task 1. Pretty straightforward. Task 2 is the same kind of thing. It's like another page. This one's a little bit different though. Task 1's kind of focused on that, that 90s web style. It's just text and information. Whereas task 2 is a little bit more visual, right? So there's no text, but the flip side is there's a lot of visuals. So we're asking you to actually build we're not asking you to build a Tetris game. We're asking you to build a web page that looks like this, right? It can't be an image. It actually has to be like, maybe some boxes. Like these could all be boxes of different colors and various other things. And, this one, I wouldn't call it easy. I wouldn't call it hard. It's just different to the first question. It's definitely harder than the first question, but, it's a very different question as well. Someone asked, does it need to be responsive to different sizes? No, it says so here. Static fixed size page, static fixed size page, and we give you the specific dimensions it has to be. So the thing is, with the first 2 tasks, we don't actually want to we don't want you overthinking the responsive stuff. We're happy to just have you build to like a really static size. For task 3, though, we'd actually like you to build a responsive web page. So this is the web page we want you to build. Title up here, some images, some text like this, gray box at the bottom, couple more images, different text sizes, emoji. There's lots to that. And with this one, we actually give you the assets as well, right? So when you look at this page, you think, okay, well, I get the text and the colors and stuff, but how the hell do I get these 6 images and how the hell do I get these Apple Store things? So in any case where like something needs assets, if you actually go into the folder, like task 3, there's actually an assets folder where we give you all the assets, so you can actually just like source these directly. You don't need to worry too much. Yep, that's really all there is there. SVGs are allowed, as you just probably saw. Some of those are SVGs. I think we talk a little bit about, we have a lecture that comes out in week 3 or 4 about SVGs. It's not really critical to understand them now. SVGs are a different way of displaying visuals, like bitmaps, JPEGs, GIFs, PNGs, SVGs. SVGs are a bit different than the others, but fundamentally they're just visuals encoded in some different thing. Okay. The thing with the responsive task, though, task 3, is that we give you the full size like desktop page, then we also give you the mobile page. So this is what it would look like on like a mobile. And we ask you to build this page responsively. So what that means is that, like, if you look at GitLab, right? With GitLab, if I was to make this smaller, you see how GitLab kind of responds in different ways. GitLab does a few more complicated things, but what's maybe a more appropriate website? Something that would just squash content down. I don't know, maybe this. This bit here. See how it just adjusts for different sizes? We have a responsive lecture that comes out in week 3, I think. When I say it comes out in week 3, I mean it comes out in week 2, but it's a week 3 lecture with some basics of that. And we can talk about responsiveness next week as well. We can talk about things. We can talk about whatever people want to talk about on Thursdays. It's totally up to you guys. I'll always have about an hour of stuff to talk about, and then I leave the rest of the space open based off what people are talking about on the forum or fill out on the feedback. Sorry, I've lost the page. Where is it? Here? Okay. So that's task 3. The page isn't too hard, but the responsive part might be a little bit challenging for some people. There's a couple of other requirements here. And then task 4 is building a dynamic form. So task 4 of this assignment is actually pretty much nothing to do with HTML and CSS. It's all JavaScript. Task 4 is here because we assume that you know what, how would I put it? Like, we assume that you, by this point, are up to the JavaScript stuff. So like most people will spend the first couple of weeks trying to get familiar with HTML and CSS, and then by the time you get to like the second week, third week, you'll be playing around with JavaScript more, and that's what this is for here. So dynamic form, this question is basically asking you to make an HTML form, and depending on the different inputs people put in, you'll get different outputs. Yeah, it's very JavaScripty, and it's kind of meant to start warming you up for the second assignment, which is like a huge version of this. So this isn't HTML, CSS, it's a very different thing. That's kind of it. Then there's some help at the bottom of this, like analyzing pages. Like we give you these images, but how do you actually analyze them? Like how do you figure out what those colors are? How do you figure out how big things are? We give you some advice here. There's an online tool you can use that's like Photoshop. It's pretty easy to use. We ask that you use Chrome for browser compatibility, and the standard things. The marking criteria is pretty straightforward. Half your mark comes from does it look right before we even open your code, right? So we just look at your page in the browser. Half your mark comes from that. And the other half of your mark comes from code quality. And what we mean by this is like, is your code neat? Does it avoid inline CSS styles? Some things I'm saying now might not mean a lot to people because you haven't watched the pre-recorded lectures. So maybe it's worth like, watching the week 1 HTML CSS lectures and then kind of coming back to this stuff because it'll make more sense. Like this criteria will make a lot more sense. It's pretty straightforward stuff. Obviously plagiarism is a clean zero. If you copy other students' work or you copy code from the internet and you try and reverse engineer it, we will find you. Plagiarism detectors will find you. Tutors know what to look for. We have all of last cohort's source code. Not that that matters too much because they got different questions. But yeah, just be very careful of that. You don't want to get a plagiarism hit on your against you. And also just to anyone who is thinking of plagiarizing, like, I don't know what the hell you're doing, just generally. Why you'd pay money to not learn, but also like, it's just gonna hurt if anyone does want to try and copy their friends, because this is the assignment where we teach you how to do stuff so that you can actually do it properly in the next assignments. Do you know what I mean? Like, copying someone's stuff is just gonna hurt you. So do your best to do it yourself. In terms of due date, I pondered making this Monday. So this is Friday of week 3, right? So it's 2.5 weeks away. I pondered making this Monday, like Monday of week 4, but my problem is like we release assignment 2 on the Sunday of week 3, and I just really don't like the idea of people submitting assignments like the same day that there's a lecture that we're talking about. Like, I think people. I mean, we could obviously make this due in week 5. Nothing's stopping us except the fact that we need to mark it and move on. But I think it's really good if people can submit this, actually have their weekend to do other things, whether it's take time off or do other assignments, and then we get on to the next thing the next week. And also, I don't think it's that bad because it's 2.5 weeks. Like, from this Friday, you have 2 whole weeks to do it. Students always email me that, and there'll always be someone that's like, "Oh, this isn't fair because I feel like I'm missing a whole weekend." It's like, you have 2 whole weekends to do this assignment. You have this whole weekend and next whole weekend, and then 3 full business weeks to do this. So there's plenty of time. Just start it early. You can go and watch the lecture. You can literally go and watch the lectures. You can literally go and watch the lectures and start it tonight if you wanted to, or start it tomorrow. It's not a hard assignment to start. And I would encourage most of you to start it soon. It's just good. There are hard ones to start. Assignment 2 and assignment 3 might feel like a hurdle to start, but this one does not feel like a hurdle to start. And yeah, it's the same thing. To work on this assignment, you just clone it. And then, if you have your assignment, you just git clone the assignment. And then after you clone it, you just do stuff like, you like modify a file, blah, 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 and you do your standard git status, git add, you can add everything. git commit doing things and then git push, and you can push it up. Someone asked before, do I need to create a dev branch for daily commit and master branch for final submission? No, you're working on this alone. I wouldn't bother. I think it's too... I don't think you have much to gain from that. I would just push it to the master branch. Why do we use GitLab? There's a whole bunch of reasons. It's a super easy way for us to deploy work and deploy updates. If we make changes to assignment 1, as in like a student's like, oh, there's a typo here, or there's something that makes no sense, can you clarify it? We actually make commits on our end, and then we automatically deploy it. So you'll actually get like commits pushed to your repo that are updates. Keep an eye on the merge request tab, because sometimes if our system can't automatically merge our commits into your repo, it creates a merge request for you, which you'll have to merge in. That shouldn't be a problem though, because pretty much all the changes we'd ever make are to the README, just the main spec file. Was I thinking about GitLab? Yeah, so I just keep pushing to the master branch. I really wouldn't worry too much about... Oh yeah, the other reason we use GitLab is because it helps you version control your software. It helps you have a backup of it, so you don't lose it. And also it helps us keep a history of things. So, if we think you plagiarized and we can see that there's a history of you working on it every day, then we know you didn't plagiarize, right? Or you're just a genius. You're so smart to not know what you're doing and somehow play, I've never really understood that, but that's okay. Yeah, that's about it. That's about it on assignment 1. I don't think I have much else. So what we might do is just do some questions, see people have questions about the course, assignment, getting started, just for the last 20 minutes until we run out of questions. That's a very specific question. Vishal, sorry, I always terrible with pronunciation still. Says like, what's the difference between git add dot and git add all? I don't know. I think the git add all will also include files that have been deleted, perhaps. Like if I git status, like if I rm task1 index, and then I git add dot. No, it does it still. I don't know. I feel like there was a reason I used to use it, but maybe not. But, it's all the same. If people want me to go through something today or like cover a topic more, we can also do that in the last 20 minutes. Very happy for whatever. Otherwise, we can do it next Thursday too. You don't have to tell me now. We can always post on the forum and stuff. It's also hard with this first lecture because I'm aware that many students haven't watched the pre-recorded lectures yet. So, I wouldn't want to show you anything that's in a pre-recorded lecture because you'll just watch that. So it's more like if people have questions that expand upon that. What kind of software development tools do we use? I mean, I mainly use Sublime for my stuff, but generally a lot of students will use what's it called? They'll use just VS Code. And some will use some JetBrains software and stuff. So, something just happened. Okay, closed. Manpreet, it says in assignments 1 criteria, CSS, let's have a look at it. CSS is appropriate structure to be placed in external style sheets rather than inline styles. Basically what we're saying with this is that we want to see all your CSS in an external file. Like, I understand what you're saying. You could have style tags up the top of your page, but for the first assignment, we're trying to be a bit more strict and say we want you to place it in external style sheets, which is basically putting it in the style tags, but in another file, right? So, yeah, is there any chance we could open more on-campus tutorial lab groups? Or perhaps you could migrate people who don't attend their full... the migrating people who don't attend, yeah, we can have a look at that. for sure. Opening them, I don't have any power there at all. So, yeah, sorry about that. Alvin's answered my Git question. Thank you for that. Vishal says, would we be able to make mobile phone apps by the end of this course, or be able to do them with a little more learning? Yes, you'd be able to make a certain type of mobile phone app, which we will talk about later in the course as well. So, will there be any guest speakers? I think this goes to a question someone asked earlier, which was, are many of the industry people live lectures? So I think there's going to be a couple of live lectures. Like I think Zane's going to do a live lecture sometime in week 8 or something like that. But mainly speaking, mainly throughout the course, the pre-recorded lectures will be industry, and I'll mainly be doing the live lectures. But I will do a couple of pre-recorded, and industry will do a couple of live lectures. Ang says, as of now, do we only install Node.js or others like React.js are required as well? Okay, so there is a lecture on Node that I think I talk about a bit in NPM intro, but the best way to understand things is that browsers are capable of running JavaScript, HTML, and CSS. Right? Your browser is actually an interpreter for it. Like, you know, let me just open VLab again quickly. So, you know, if I open my terminal and I create a file called page.html, and inside of it I do bold, italics, hello, end italics, and bold, right? This is a program. Now, you know, if you write some Python and you want it to be interpreted, you do like python myfile.py, right? And the Python program will take that source code and it will interpret it and do something with it. Browsers are really just interpreters of HTML, CSS, and JavaScript. So, for instance, if I try and open page.html in Firefox, the browser will interpret that source code and give me some output. So, ironically enough, the web browsers that you all have installed on your machines are half the tools that you use, and they actually probably will do the most work in the course, right? Because most of what you do is, like, assignment 1, the tool you're using is the browser in a lot of ways, right? Like, that's the equivalent of the interpreter. You'll obviously use editors and stuff. I still think Sublime is fine, but I'm a dinosaur, I guess. VS Code, though, is probably the way most of you would like to go. Yep. But someone asked about Node.js. So when you install Node.js, and you can use Node on the CSE machines, like this, and the Node lectures are coming out soon, and Node itself is a little bit like pip, with, you know, like pip in terms of Python, like it's a package manager and stuff. So funnily enough, after you install Node, all those things like React.js and all that other stuff can actually be installed with Node itself. So from a system install perspective, as long as you have, you know, an editor, Node.js, and a browser installed, you can kind of do everything from there. And the Node.js part you don't even really need until week. Well, I mean, you'll need it before for the exercises if you want to do them, but in terms of accessible content, you won't need that till week 4. Yeah. And with your assignment, that's like literally all you have to do is you just open a page. Like, you know, I could do it right now. I just open a page like this, and then I just open my page in a browser like this. And then I can just come along and start, you know, what would it say, like, H1 title, you know, save, refresh, I got more stuff. If you're doing something locally, you can usually install browser add-ons and stuff. or the VS has like a live code thing. There's like so many different ways to do it, but usually like with VS Code, it might automatically refresh your web page after you save. If you're just using like a normal editor like me, you can set up a thing where your web page will refresh like every 1 second. And yep, that's it. And then you can like kind of edit things more rapidly because you just hit save and then it like just refreshes like this repeatedly. I might even be able to do that on CSE machines. I don't know. I don't know if you can install add-ons on CSE machines. Refresh. Maybe you can. Tab reloader. Wonder if it'll let me. Add to Firefox. Yeah. Done. Is that it? Tab reloader. Enable reload for this tab. Every 5 minutes. No thanks. How do I change that? Change that to seconds. Bam. Okay. Now it is reloading? Permit codec? I don't know. Oh, there we go. No, it's just reloading slowly. Who knows? Time left to refresh. Okay. Anyway, there's lots of things you can do with this. Sorry, I got on a tangent. Kevin says, is installing Node.js as simple as running sudo apt install Node.js? Yes, it is. I already have it installed, obviously, but if I just ran that, it would just install it. It would probably work similarly on different Linux distros. It would work similarly on OS X. Though in many cases on OS X and on Windows, you can just Google Node.js and you'll typically get given a binary of some sort. Like here I am on Windows, I'm like, yeah, I'll install Node.js, and I click on that and it downloads it and then I install it. It's really, really easy. Like if you were just like, oh, I'm gonna try and install it, you just install it like that. No, you don't need to worry about versioning. Generally, if you just download some standard thing, it'll be fine. Like, if you start downloading like version 10 or something, then you might have problems. But if you just download whatever's on the website or whatever's on the apt repository, you'll be fine. And yeah, we will put out some slides, not a video, which gives some instructions to install it, just to help people along. But yeah, my point here was just, this is how you start assignment 1. It's really easy. All you need is an editor and a page, and you just write some code. And, you just try and make it look like the images. You could do the whole assignment with just 3 windows up. Code, the image you're making, and the page as your code renders. So it's a nice little introduction to the course. We want to make it like a breezy, relaxing first assignment before we crush your souls, I guess. Well, not really. That was like 80% joking, but cool. Any other questions? Assignment 2 and assignment 3 were actually getting you to build like proper apps, so they're just bigger projects. Assignment 1's like make a few pages. Assignment 2's like build a little web app. I wouldn't call them like it's not disastrously difficult. Like it's not like one of CSE's most difficult courses by any stretch, but you need to spend time with it. Yeah. Do we have a browser limitation? I don't know what that means, but I assume you mean like, do you have to use a particular browser? So we ask that you use a certain Chrome version. I mean, this version is not fancy. In fact, I found it just by going to my Chrome version and seeing what it was, because Chrome updates itself automatically. So if you have Chrome installed, you probably have that version. You can develop in something else, but make sure you just check it on Chrome or on VLab or something. Because like if you develop it on Safari or some weird browser, it might look different when they go to market, and we don't want you losing marks. So Zenji says, we do the assignments through GitLab? So here's, for those who aren't familiar with GitLab, I want you to think about it like Dropbox, right? So if you would ask me the question, do we do our assignments through Dropbox? It's like, Well, you do your assignments on your own computer, but they're stored on Dropbox. That's where they're backed up. That's where they're stored. You're just working on it locally and syncing to it. Um, and if you're not familiar with GitLab, that's perfectly fine. Two things about that. One again is you can use the resources we provided that I mentioned earlier in the. Oh, I already had the installing Node.js thing here. Sorry guys, I already put this up. The Node.js installation is like written here, so that's fine. But also, if you're struggling with GitLab, pop into one of the help sessions. The tutors would be really happy to help anyone, particularly postgraduate students with Git. Just ask them like, okay, how do I start something, anything? They're really happy to help. So, yeah. Any other questions before we wrap up tonight? G Chen says, "Will it auto save my code?" It won't auto save your like. Whether your code is auto saved locally depends on how often you save it and what editor you're using. It gives you a chance to sync your code to the cloud when you want to. You don't even have to sync it that often. You could literally just do it all locally and then push it at the end. It's not a barrier. Like, I just want to stress this to people. It's like, in the worst case, when someone doesn't know Git, a tutor could help you in 10 minutes learn as much as you need for the entire assignment. So, Carol says, "How do we change the window size?" I'm not too sure what you mean, Carol. Maybe I'll try this out. So, when the assignment question says something like, "This is 420 by 699," right? You can do a couple things. One of the first things you could do is, if you really want to, you could make a div. Again, go watch the lectures if you haven't yet, otherwise this will be confusing. You can make a div with width 420 pixels and height 699 pixels like this, and you could give it a border of 1 pixel solid black, right? And then you can do everything inside this, and then that gives you a nice clear border to work in, right? So this is one way of doing it. It's just giving yourself a border to work in. The other way you could do it, if you want to, is you could make your page normally, except you could make your browser a certain size. And the easiest way to do that is if you press F12 on your browser, and then you click on the mobile item here, you can actually punch in the size you want. 420, 699. And that'll be the size. And now you can actually work to that and refresh the page, and everything will be scaled to that. So they're two very different ways to kind of control the space you're working with. Schofield says, "Do we need to clone the code on VLab and update it through Git, or both VLab and local machine are okay?" Yeah, no, you can use VLab, you can use a local machine, whatever you want. You don't need to touch your CSC account in this course. Like, the only actual CSC system that you have to work with is GitLab, really. VLab's just there to help people who like, Node's already installed on VLab. Some people just like to use it. I wonder what the difference between Vanilla.js and React.js is. We're going to be talking about that a lot more, particularly next week, so I won't cover that now. Alright, well, rather than kind of go through the question cycle, I'll just say, if people have any more questions, just post them up on the forum. I'll get to them. In general, I try very hard to make sure that I've answered all the questions I've gotten that day before I go to bed. So think of that as generally you'll have a 24-hour turnaround. Depending on the day of the week, sometimes it'll be much quicker. Like Mondays, Tuesdays, I'm very busy. So usually it's like a thing I do
in the evening to sort it all out. But other days of the week it'll be quicker. So anyway, nice to meet you all. Looking forward to kind of seeing you every week and having you here in the course and seeing how you find it. Feedback's always welcome, and I hope you have a great evening. Enjoy what little of summer is left.